In this video, we will learn about the concept of distance and displacement. So basically, we're going to learn what's the difference between distance and a displacement. So I'm going to start with distance. So the length of the actual path traveled by a particle between initial and final positions of the particle in a given interval of time is called the distance covered by a particle. So let's say we have a particle that goes from position A to position B and then to position C and then back to position A as shown in this figure over here. Let's say this distance is 1 meter or 2 meter, any number. Let's say 4 meter. Just say it. Okay. And so the distance traveled by the particle in in a given time is equal to A to B plus B to C plus C to A, which is basically 1 plus 2 plus 4. And let's say this distance is in meters. Okay, so this gives me 7 meter. Okay, and the units of distance in CGS system are centimeter, and we write it as cm, and in SI unit system it is meter, and we denote it by m. Okay, so distance is a scalar physical quantity as it has only magnitude. Okay, so we have only magnitude that tells us the size of the distance. Okay, and no sense of direction, so we can't tell which direction we are moving. See, this is different, this is different, and this direction is different. So we have like this direction, this direction. So there is no particular direction in this case. Okay, and distance traveled by a particle or a body in a given time is always positive. Okay, things to remember. Okay, distance. So first thing, distance is a scalar quantity. Okay, so distance is a scalar. Second thing, distance is always positive, always positive. Okay, and distance traveled by, let's say, cars or any vehicle, we use a device called odometer. So you might have seen on your car there is a device, or there's a uh, on the display it says odometer. It tells you how much distance the car has traveled so far. Okay, so that's about the distance. Basically, the length of the actual path traveled by a particle between initial and final position. So this was our initial position. We keep going this, and when we came back to our original position. So our initial and final position is same, but we traveled some distance. Okay, so we basically add all those paths. And now in case of displacement, which is a little different compared to the distance, displacement is a change in the position of a particle along a particular direction in a particular time interval. Okay, or you can say the shortest distance from the initial position to the final position of a particle is called displacement. So let's say this is origin O, and particle is at A, here already at A. Okay, and so I'll say this is my initial position. From the origin it is xi. Now it traveled to point B here. Okay, so it moved from A to B, but from the origin the distance is xf. Okay, so the displacement is the change in the distance, okay, which is xf minus xi. So we represent it by delta d. Okay, so this gives you this part over here. So this is the displacement of the particle from A to B, which is basically final position minus the initial position of the particle. So final position is at B and the initial position was at A, which is xi. So xf minus xi gives you the displacement. Okay, so that is your displacement. So I'm gonna write it here. So xi is my initial position on a number line, let's say initial position, and xf is final position, and xf minus xi gives me the displacement. And the note to take here, displacement is a vector quantity, so is a vector quantity, as it has both magnitude and direction, like in which direction displacement is happening. In this case, the displacement is happening in this direction here. Okay, and second thing, displacement can be, it can be 0, positive, or negative. Now let's go back to our distance example over here. So in this case, my initial position and the final position are same, so we came back to the same point. So what should be the displacement? Think about it. So if we go back over here, so my initial, final position and initial position, they are same. So that means if those two numbers are same and you subtract them, that'll give you 0. So in that case, displacement is 0. So in this example, the example we used for distance, displacement is equal to 0. What distance is 7 meter. Okay, and the units for displacement in CGS, again it's a distance with a direction, centimeter. SI units are meter. Okay, so there, let's go over examples when uh, displacement can be positive or negative or 0. So let's use one example over here. Let's say like this example here. In this case, you see xf, this number over here, is greater than xi. So you're subtracting a smaller number from a bigger number. That will obviously give you a positive answer. So that gives you displacement is equal to positive. Okay, and 0 example we already saw over here. You know, when the initial and final point is same, displacement is 0. So let's go over example when displacement can be negative. Okay, so let's say here, so I got 0 over here. Let a particle moves from, let's say particle is here at A, and it moved from A to B in this direction. So it moved over here. So this is 0 on the number line. So particle was at A. Okay, so I'm gonna say this is xi. Okay, and it moved to this point over here, B. So this is my final position. So this is my xf. All right. So if I write displacement, so displacement was xf final position minus initial position. Okay, but as you look on this number line, final position xf is smaller than xi. So xi is bigger. If you subtract a bigger number from a smaller number, you get negative value. So that tells you displacement is negative. So for example, let's say this was 5 meter. So particle was at A at 5 meter from the origin, and now it moved back to, let's say, 1 meter. Okay, so that tells you xf is 1, xi is 5, so 1 minus 5 is going to be negative 4 meter. So you see displacement can be negative. Okay, so those are some basic examples you can use to differentiate distance and displacement. Okay, so let me sum them up over here on this page. So distance is the length of the actual path traveled by a particle. Okay, so distance is actually the length of the actual path, whereas displacement of a particle is the shortest path. Okay, displacement is shortest path. So distance traveled by a particle is always positive. So let me write down here. So distance, and I'm gonna say displacement over here. So distance is always positive, whereas displacement is going to be either positive or negative or can be zero. The third difference is distance is a scalar quantity. That means it has only magnitude, no direction. Where displacement is a vector quantity, it has magnitude as well as direction. And the fourth difference is the distance traveled by a particle depends upon the shape of the path followed by the particle. So it depends on shape of the path. Depends on the shape of the path. Okay. Whereas displacement does not depend on the shape of the path. I'm going to give you an example for that. For example, let's say I got a particle that moved from here to here. It went this way. So let's say A, initial point, B is the final point. So distance will be this whole length of the actual path. Okay. Whereas displacement is the shortest path, which is just join A and B, make a straight line. So this is my displacement. So it moved from point A to B. We don't care about the shape, the path it followed. So this is distance over here in this direction. Alright. So those the four different you guys can remember to differentiate between distance and displacement. Alright. Practice few examples, like you can draw a shape or whatever to figure out what can be the distance and what can be a displacement. And always remember, displacement will be the shortest path, does not depend on the actual path of the particle. Okay, so thanks for watching the video, guys. I'm gonna make few more videos, like next will be on average velocity and average speed, and then we'll solve some numericals or problems over those. Okay, thank you for watching the video. Please share with your friends, and please do not forget to subscribe to the channel. Thank you. Have a good day. Bye bye.